Today we're going to look at some review of algebra concepts. And these algebra concepts are going to help us throughout this semester of geometry. So notice that the first couple of problems, I'm asking for us to solve equations. Okay? Equations are something that you've been solving for quite a few years now, and it's something that we'll be continuing to do this semester. So notice that in the first one, if I have 114 equals 8 times the quantity n plus 7 and then minus 6. So remember, we want to solve for n. N's in parentheses. Let's get rid of the parentheses by distributing that 8. So by distributing the 8, we'll really then have 8n plus 56. And then we still have minus 6. Since that was not in parentheses, we don't multiply that by the 8. Okay? Then I have some like terms that I can combine on the right-hand side. 56 minus 6 is going to give us a positive 50. Now we just have a two-step equation to solve for n. We always want to move the number that is not attached to the n first. So since 50 is positive, we are going to subtract it. 114 minus 50 is going to give us then 64. And then finally, to solve for n, we have to divide both sides by 8. So that will get us the value of n by itself, and 64 divided by 8 is going to be 8. So that is what n is. If you're ever unsure of your answer when you're solving an equation, you can always take that 8, substitute it back into that n in the original problem here, and make sure that the left side then equals the right side. Moving on to the second problem, we've got negative k minus 5 equals negative 3 minus 2k plus 3k. So we want to solve for k. I noticed that on the right-hand side, we have a couple of like terms. So I am going to combine those first. So we'll still have the negative 3 on the right. Negative 2k plus 3k would just give us a positive k. Now I've got variables on both sides. So I want to move one of the variables over to the other. It doesn't matter which one we move. I think I'm going to move the negative k from the left over to the right-hand side by adding. So that would still leave me with a negative 5 on the left. We'll still have a negative 3 on the right. K plus k is now a 2k. I'm going to move that negative 3 over by adding it. So that gives me then negative 2 to equal 2k. And then finally, I'll divide both sides by 2, and it looks like we get a k value of negative 1. Problem number 3, we have negative 6 times the quantity 5k minus 3, and that equals negative 26 minus 8k. So we've got parentheses on the left. I'm going to distribute the negative 6, throw out everything in parentheses. That would give me a negative 30k plus 18, and that's going to equal negative 26 minus 8k. So once again, we have variables on both sides of the equation. It doesn't matter which one of those we want to move. So this time, I think I'm going to move the negative 8 over to the left-hand side by adding it. So then that's going to give me a negative 22k plus 18 to equal negative 26. I'm going to then move the 18 over by subtracting. So negative 26 minus 18 is going to then give me a negative 44, where then my last step to solve for k is to divide both sides by negative 22. And remember, a negative divided by a negative is a positive, so we'll get a positive 2. And there are my answers. In problem number 4, it's asking for us to solve a proportion. So proportions are actually something that we're going to be talking a lot more about in this particular new geometry chapter. But when we have a fraction equaling a fraction, you've probably seen this in algebra. What we want to do is we want to think about cross multiplication. So what I mean by that is the numerator on the left is going to get multiplied by the denominator on the right. So 2 times x is going to give me 2x. I now get to set that equal, and then I'm going to take the product of the numerator on the right to the denominator on the left. So it's going to be 6 times 4. Well, 6 times 4 is going to give me 24. And so then my last step to solve for x is to divide both sides by 2. and it looks like we get x to be 12. All right, moving on. Now we have quadratics. So it says solve each equation by taking the square root. So remember, a quadratic is because we have a squared term. In this first one, we have an n squared term. In the second one, we have an x squared. And then this last one, we have an x squared. Okay, so squared terms. If it's asking for us to take the square root, what we want to do first is isolate that squared term by itself. Well, here in problem number 5, n squared is already by itself. So then the question is, how do you get rid of a square? Well, I'm telling you exactly what we want to do. We want to take a square root. So if I take the square root of the left, I have to take the square root on the right. So that's going to get me the n by itself. But now here's the thing about square roots. When you have an equation and you take the square root of both sides, you don't just have one answer, you actually have two. You're going to have a positive answer as well as a negative answer. So that's why I usually put a plus or minus sign in front. The square root of 16 is a perfect square. I can find two of the same numbers that multiply to get 16, and that would be 4. So positive 4 and negative 4 are my answers. So if instead you want to write it as a positive 4, comma, negative 4, that would be the exact same answer. So you can do it where you just have the plus or minus sign in front. Otherwise, you can separate them. If I look at the second example, 9x squared equals 225. Well, x squared is not by itself. There's a 9 with it. So we cannot take the square root until I get the x squared by itself. So because that's through multiplication, I'm going to divide both sides by 9. Okay, so that's going to get me x squared by itself. 225 divided by 9 is going to give me 25. And now that I have the square by itself, I'm going to take the square root. And if I do it to the left, I'm doing it to the right. That will get me then the x by itself because a square and a square root cancel. And then because I took the square root of both sides, I will have two answers, both a positive and a negative. Square root of 25 is a perfect square. Remember, we can find two of the same numbers that multiply to get me 25. That would be 5. So plus or minus 5 would be my answer. And then finally here in this last one, notice that the x squared is not by itself. There are more than one number on the same side. So just like what we did in previous examples up at the top, I got to get the x squared by itself by first moving numbers not connected to it. So the 10 is on the same side but not connected. So I'm going to subtract both sides by 10. That's then going to give me 108. I will then divide both sides by 3. And so that will get me then the x squared by itself. 108 divided by 3 is 36. Now that I have the square by itself, I'm going to take the square root of both sides. Taking the square root of a square gives me then just that x by itself. Because I'm taking the square root of an equation, we will have two answers, both a positive and a negative. Square root of 36 is another perfect square. I can find two of the same numbers that multiply to get 36, and that would be 6. So both positive and negative 6 would be my answers.